Hello friends, continuing with Gauss law, today we take up applications of Gauss law. Gauss law is a fundamental law and can be used to find electric field intensity due to a point electric charge as well as charge distributions, whereas Coulomb's law is applicable only to point electric charges. I repeat, Gauss law is a fundamental law and can be used to find electric field intensity due to a point electric charge as well as due to charge distributions, whereas Coulomb's law is applicable only to point electric charges. Now 7 steps to find electric field intensity using Gauss law. A. Identify charged and closed. B. Identify point where electric field intensity E is to be determined. C. Identify Gaussian surface. D. Calculate charge enclosed by Gaussian surface. E. Calculate electric flux linked with Gaussian surface. F. Use Gauss law. Phi E is equal to 1 by epsilon 0 times QEN, that is charge enclosed. G. Calculate electric field intensity. So these are 7 steps to be followed in order to deal with applications of Gauss law. Okay. Now 4 applications of Gauss law that we are to discuss here. First, to find the electric field intensity due to a point electric charge at a distance r from it. Second, to find electric field intensity due to a uniformly charged spherical conducting shell at any point at a distance r dash less than r less than equal to capital R, where small r is the radius of the shell. That is, number 1, outside the shell for small r less than capital R. Number 2, at the surface of the shell, that is for small r equal to R. And third, inside the shell, that is r dash less than small r. So these are the 3 different cases we have to deal with in the second stage. Third, to find electric field intensity due to a uniformly charged thin infinite rod at a distance r from it. Fourth, to find electric field intensity due to a uniformly charged thin insulated infinite plane sheet at any point near it. So these are the 4 applications that we are to deal with. Let us take up first application of Gauss law to find electric field intensity due to a point electric charge at a distance r from it. And we are to follow 7 steps as mentioned earlier to find the expression for electric field intensity. A. Identify charge. Let us identify charge first. Consider an isolated point electric charge plus Q lying in any region of space as shown in diagram. B. Identify point in the region. Now let us identify point. Let P be any point at a distance r from the charge where electric field intensity is to be calculated. C. Identify Gaussian surface. Assume a closed hypothetical surface in the form of a sphere of radius r around the charge with its center at the charge q, such that point P lies on its surface as shown in diagram. D. Calculate charge enclosed. Now charge enclosed by Gaussian surface is equal to Q. You see in the diagram the Gaussian sphere encloses charge Q only. E. Calculate electric flux linked. Let us calculate electric flux linked with the Gaussian sphere. Now, due to symmetry, electric field intensity at every point on the Gaussian surface would be same as E equal to K naught Q by R square along radius directed outward. Therefore, electric flux linked with whole Gaussian surface would be, say, phi E is equal to E dot S, or it is equal to mod E mod S cos theta. But theta between area vector S and E vector, electric field vector E, is 0. Therefore, electric flux phi E is equal to E into S, or it is equal to E into area, or it is equal to E into 4 pi r square. Let us mark it as equation 1. F. Use Gauss law. Phi E is equal to 1 by epsilon 0 QEN, where QEN is charge enclosed by the Gaussian surface. Now, substituting the value of phi E equal to E into 4 pi r square, we get E into 4 pi r square is equal to 1 by epsilon 0 times the charge enclosed, that is QEN. G. Calculate electric field intensity. Now, from above equation, we have E is equal to 1 by 4 pi r square QEN by epsilon naught, or it is equal to 1 by 4 epsilon naught QEN by r square, or it is equal to K naught QEN by r square, where K naught is equal to 1 by 4 pi epsilon naught, or E is equal to K naught QEN by r square. Mark it as equation 2. And this field is along radius directed outward and is the electric field intensity due to point electric charge at a distance r from it. So, this way we can derive electric field intensity due to point electric charge at a distance r from it using Gauss law. Also, we have derived this expression using Coulomb's law, because Coulomb's law is only applicable to point electric charges and is not a fundamental law, but Gauss law is a fundamental law. It can be applied to point electric charges as well as charge distributions. So, next 3 applications are to be dealt with charge distributions. Okay. Thank you so much. God bless you.